Hey everybody, this is Larry. This is me doing the week 2 premium challenge here in June 2024. I almost forgot the year. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. And as I was saying with the other video as well in the daily prom, I am doing this at night, 11:30 here in New York. Oh, I'm not in New York. I'm actually in Columbia, South Carolina. The thing is that it is actually the contest time during the server. I got back from a beautiful wedding that I was able to visit or attend. Yeah, I got back a little bit late for the contest, so I'm just not gonna do it. But yeah, the videos will come out. But yeah, so I'm trying to just do the weekly farm and catch up. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Yeah, today we have, or this week, if you will, 2083. Substrings that begin and end with the same letter. You're given a zero index S consisting of only lowercase English letters. You return the number of substrings that in S that begins and ends with the same character. Okay, I think this is one of those problems where you may see solutions that are very cryptic and you're like, oh, this is like 5 lines of code or whatever, and you have no idea how it works, but I think there are a couple of ways you can think about this problem and kind of break it down, right? The first thing that you can do is just, don't be too clever. I think, especially during a contest, sometimes you just want to get something working, and maybe that working solution is a little bit too slow and you may get time limit exceeded, but it is better than nothing. And the way that I would first initially think about this, maybe, full disclosure is that I don't remember this problem per se, but I've done similar enough problems. Definitely this one. I probably have done this one. I'm not gonna lie, but I just don't remember it because I'm not here to show you how good my memory is. I'm here to maybe show you how good my problem solving is, right? So I don't remember these things because it's not worth my time to remember it. But my point here is that it's okay to work incrementally, right? And the way that I'm going to start this problem off is not the way that my experienced self is going to do immediately. But nonetheless, the first way that I would break it down is by looking at each character one at a time, right? So, and then in that way, you can, like for example, count the number of A's, count the number of B's, and so forth, right? And after that, then you may notice that, oh, well, how many string? The key thing to note is that the endpoints of a subarray or substring in this case, they're kind of, I don't know what the word is, but they're just fixed in a way, right? And what I mean by that is that every beginning has to be in a B and every end has to be a B, right? Then so everything has to match. So only the B's matter, and it doesn't matter whether, like, if you have, I guess another way of saying it is if you have a string that's BB, that counts as 1 to the answer, right? And it doesn't matter if you have like a lot of random stuff in the middle, this is also counts as 1, unless I hit B by accident somewhere in the middle. But yeah, it's just, they all count as 1. So in that way, you can see that the inner stuff doesn't matter, right? So then now, if you reduce this problem to counting the number of each characters, and so you can maybe do something like collections.counter, and then the thing is that if you know combinatorics, then now you're saying, okay, maybe let's say there are 10 B's. How many ways are there for the beginning and the last letter, right? Well, in this case, remember that you could have one string. So let's say you have 10 B's, right? Then now, and we only have 2 things that we have to choose. We have to choose the beginning and an end, right? And then now the beginning, we have 10 choices, right? And then the end, well, it depends, right? Because because then now the first one is 10 plus 9 plus 8 plus 7 plus ... right? And that's basically it, because if you want to visualize it, that's close to 10. I don't know if that's actually 10, right? If you have, this is the beginning, then they only want, you count this current one and then all the way up to it. So that's why there's 10. If it's here, you can't choose the one before it as the ending, right? So then you have this summation, right? And as a result, this summation is actually is it n choose 2? It's not actually n choose 2 because n choose 2 does not repeat, right? So you have to add, so then it becomes like n choose 2 plus n, because n choose 2 means that you don't choose the beginning and the end using the same one. So if you add n to add back all the one character or one length solutions, then that's how you get it. So first we do a frequency table, and I'm just being lazy here in Python. It just puts everything in the frequency table, right? And then now we can maybe say total is equal to 0 for I don't know, k for keys in f.keys. Then total we add by as we said, k choose 2, right? K choose 2 plus k. Oh, no, not k, sorry. F of k choose 2, because that's the number of items we have, because the k doesn't matter. And that should be good unless I'm off by 1, which happens a lot. But yeah, the idea should be good, right? I forgot that we're doing a contest, or by doing it during a contest is running, so we are going to have some submission issues. So I'm going to go right ahead, assuming this is good. But this is not the way that I would naturally write it, though this is actually also like 6 lines of code, and it's pretty good. I'm going to submit it, but seems like I haven't done it before. It's either that or it's loading. It's hard to tell because I don't know. But this is not the way that I would naturally do it, because it's just not natural. And also because it does 2 passes, which is fine. But the way that I would maybe do it is just 1 character at a time, which is more into, I don't know. I think it depends on the problem, but it's just that it's very rare that you get a very simple fixed, or like, what's it called? Ooh, okay. That was much lagged. But it's not, I like to do it this other way because this is just very specific, right? It's not very common that you get a formula that you can just be like, oh, it's just n choose 2 plus n, right? Usually you have to do some like, there's if statements, they're processing, and after that, no one knows what the formula is. And for that, I want to say something like this, right? We keep track of the frequency table, and we have a C, we have a total. And the idea here is just for each character, I like this idea of contribution, and if you watch my channel enough, I talk about contribution a lot. And it's just this idea of contribution is, okay, if C is the last character, or the, what's it called, the ending, n index or character, how many are substrings end with C, right? And that, so then now we go, okay, well, because itself can be 1, so then we just, we add 1 to the number of time it appears, which makes sense, because if, for example, if B is 9, you add 1 because this is the 10th B that we see. And then now we realize that we have 10 Bs, and all 10 of them could be choices for being the first B. So then you add, so then you do something like this, and that's it, right? So, and then we return total. Yeah, and this is slightly more natural to me. There are also other considerations as well, to be honest. I don't know if it's going to be fast or slow. It doesn't really matter. But it's just that this way, and I'm not, you could experiment and play around with things to figure out what is good for you. But this is more natural to me. And the reason is what I said, right? Because there are a lot of, like, if there are more constraints and stuff like that, there are if statements that you could take care of, and take advantage of and stuff like that. I don't know why this is so slow, but this is maybe this the counter thing. But I don't know. But you can also just use an array of 26 elements. I'm not sure why, but I don't care that much. I think the server is just having silly issues. But yeah, and then the other thing is that, for example, with the other solution, because you have a fixed formula, it can grow really fast. I mean, n choose 2 is actually not that fast because it's n square, right? N choose 2 is O of n square. So the number doesn't get too big. But maybe there are other way of calculation contribution where you may have to deal with a mod. You have to do a modular, that is modular math, and maybe you have to do some complexity. Well, all that is just much cheaper to do with stuff like this, because you can break it down more, like in the smaller chunks. I'm trying to find the word, but it's fine. Yeah, just smaller chunks, right? So definitely these are things that to consider, and this is the why that I do it this way. But apparently, I haven't done this one. I thought I might. I mean, it looks very similar. I know that I did. I mean, I've done so many problems, that they, I thought that I just assumed that I've done it, but apparently not. But either way, you can see that it's pretty straightforward. So what is complexity here, right? This is going to be linear time because it just looks at every character. And this is O of alpha space, where alpha is the size of the alphabet, because this is just 26 characters, right? 26 things to count. And yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.